me first is Jeff Tingley. He's the head of strategy and marketing development at Exodus, which is a global energy consultancy. Jeff works extensively in helping grow the U.S. renewable energy supply chain through regional market analysis and developing market entry strategies for companies wanting to enter the renewable market. Prior to Exodus, he was vice president of business development at the Rhode Island Commerce Corporation. Next, we have Will Cotta. He is the offshore wind supply chain director for Rhode Island Commerce. Will helps local companies find their opportunity to grow in the offshore wind industry, and foreign companies looking to enter the to enter the U.S. offshore wind market. Previously, he served 9 years as an officer in the U.S. Coast Guard, where he specialized in marine engineering and marine salvage. Finally, we have Chris Waterson, who is the general manager at Waterson Terminal Services. Chris is responsible for all day-to-day activities at the Port facility, as well as heading up WTS's marketing and business development program. During his time at WTS, Chris has been directly responsible for the efficient loading and unloading of approximately 10 million tons of bulk and break bulk cargo, as well as attracting new tenants to the port, such as McInnes Cement, Deepwater Wind, GE Renewables, Grimaldi ACL, and Ørsted. Chris has also expanded WTS's operation to the ports of Davisville and New Bedford, with a focus on servicing new vehicle OEMs and emerging U.S. offshore wind industry. Welcome, panelists. We're really delighted you're here. Appreciate your time. And I'll turn it over to you, Jeff.
Great. Hi. I'm Jeff Tingley. It's great to be here. I know some of you and hope to meet more of you by the end of this session. So I work for Exodus. We are a global consulting firm. We've been in the energy space for about 20 years. We started in oil and gas, and then about 10 years ago began a transition, taking our clients from the oil and gas industry into the renewable energy. So we're headquartered in Scotland, but have an office in Boston, Providence, and Houston, Texas. And we have about 9 consultants here, and our focus here is really on 3 segments of the business. One is sort of the environmental aspects prior to a project being built, the technical aspects of how to build it, and then the supply chain and the business consulting of who's going to build it. And so what I'd like to talk to you about this afternoon is just sort of where the U.S. industry is. Where are the projects? What's the timing? What are some of the complications and some of the opportunities? But before we start, I just want to give sort of a concept of how big these wind farms are that are being built off of our coast. They have blades that are 100 meters long. They're the size of a football field. So these things are massive construction projects. And as you can see, they're 853 feet from the top to the bottom. What's interesting also is the progression of the capacity of the turbines. The average onshore U.S. turbine is 3 megawatts to 3 to 3.5 megawatts. The GE Allied turbine is 15 megawatts. So these are massive structures generating lots and lots of energy. The energy policy in the U.S. is sort of driven by the federal government. They've set a goal of 30 gigawatts of offshore wind by the year 2030. And the projects really are all on the East Coast right now, with the Northeast being the first, and they're sort of moving south. Vineyard Wind, based in New Bedford, Massachusetts, received the first record of decision. That's a fully permitted wind farm that they can now go out and build. Just to give a time scale, the time between a lease area and a turbine spinning is about 10 years. So the very long permitting process, very long pre-production purpose. There's also wind, though, on the West Coast. So the West Coast is probably going to happen in 5 years, 7 years, who knows? Some kind of guess. It's a much different type of technology. The water is very deep, so they have to float them on the surface. The ones we build on the East Coast are what are called fixed, meaning they're actually attached to the seabed. There's a tower or a frame that comes up, gravity-based, et cetera, different types of foundations. The targets are growing every day. As I said, there's 30 gigawatts, which the government says is a goal of 2030. There's now 40 gigawatts of projects sort of in process, if you will. And when I talk about in process, what I mean by is that the Bureau of Ocean Energy Management, which is a part of the Department of Interior, designates a bit of seafloor to be used for wind farms. And they then put that out for lease. So companies like Waterson, Vineyard Wind, Equinor, put a bid in to lease that piece of seabed. So they now have a lease for X amount of years. The states then say, I want to buy X amount of renewable wind energy. They provide a cost to the state approves that bid by a cost per kilowatt and other elements, and then the project starts its process. The most recent announcement, this industry changes every day. North Carolina wants 8 gigawatts by 2040. And so if you look at the number of wind farms on that slide, on that graphic on the right, you see they cover the whole eastern seaboard. What's important is it's about $8 billion of capex by 2030 to build these, and 73,000 new jobs. The message here is that offshore wind is a once-in-a-generation opportunity to grow an entire industry, to retrain, to upscale skills, and really build a whole supply chain. What the U.S. doesn't have is it doesn't have a wind industry right now. It's got companies that can do pieces of it. Most of the early projects are probably going to be built from European companies coming over here, doing their work and going back until we establish a supply chain. So we're probably 25 to 30 years behind Europe, but we'll probably catch up in 10. So there's lots of opportunity, lots of activity that's taking place in the market. So let's look at the individual areas. Our area in New England, where we sit in Rhode Island, home of the first offshore wind farm off of Block Island. Really sets us apart and sets our knowledge apart from other states. Chris and his crew are a big part of that. The regional target is 10 gigawatts. And we have that first mover advantage because we have Block Island, because we also have the first commercial scale project from Vineyard Wind, and we've got a lot of really good assets. We've got the Port of Providence, we have Quonset Point, we've got New Bedford. We have a fairly good port infrastructure to support these operations. And we're investing in foundation development, fabrication. CTV is a crew transfer vessel. You have to bring people back and forth. The closest one, I'm sure some of my colleagues here will know more. I think the closest one to shore is 17 miles off the Vineyard. Is that right?
Sounds about right, yeah.
15 to 17. So they're quite far out at sea, so you have to have big vessels to bring crews out, and these are like floating hotels. You'll bring people out for 2 to 3 week stretches while they construct, then come back into port. And there's a lot of supporting organizations, like Will's organization, my ex-organization, the Commerce Corporation, there's the New Bedford Ocean Cluster, the New England Clean Energy Council, the Massachusetts Clean Energy Center. Lots of organizations banding together to build these projects. And here's the schedule of projects from now through 2030. So as you see, there's 10 gigawatts of power actually by 2035. As you move down the coast, here's the beginning. New York and New Jersey have 16.5 gigawatts of wind planned. That is the largest current area in the U.S. of projects at this point. However, it's also the most expensive place to do business. It's expensive labor, it's expensive land, and port infrastructure. It's expensive to use the ports, and it needs a lot of investment in order to move forward, which investments are being made. Large driving a lot of the wind industry because their wind farms are so large. Don't forget that 16 and a half is more than half of the country's goal in two locations, two states, which are neighboring states. And you get to look at the size of the wind farms. South Florida being the smallest, leading up to Atlantic Shore. So you go from 130 megawatts to 2.3 gigawatts. So there are projects of all different sizes and all different timing. What's happening here, and sort of a point, is that as you get out into the 2025, 2026 timeframe, you don't see individual projects. You see massive amounts of work taking place within the same time. By the year 2026 or so, there will be 300 turbines per year commissioned. That is an industry that can't be supported by importing things and sending things across from England or Denmark or Belgium or wherever into the U.S. So there's the opportunity for all of us here. Moving farther south in the Mid-Atlantic region, which is Delaware, Maryland, and Virginia, and North Carolina, a lot of activity going on there. The biggest one is a project off of Virginia called CVOW, the Coastal and Virginia Offshore Wind, which is run by Dominion Energy. What's interesting about that project is that they built 2 test turbines in federal waters. There's 2 6-gigawatt wind turbines operating right now, which were built by Ørsted. Dominion learned how to do that from Ørsted, and now the utility is actually the developer of the wind farm. And that's a 2.5 gigawatt project with a 2.6 gigawatt project behind that. So there's also great port infrastructure as part of the country, and you see some of the expected wind farm gates and the size, and you see they range from small in Marwin and Skipjack or Maryland up to the big coastal in Virginia, and the latest is an 8 gigawatt project within North Carolina. What I'd like to point out here is that I'm talking about all the work that takes place offshore. Actually, for every 200 jobs in offshore wind, 140 of them are onshore. There's a lot of work that has to take place for transmission, grid upgrades, onshore substations. So these projects, not only, when you look at them, you can't only take a look at what's in the water. There's a lot that happens onshore as well, which creates enormous opportunities for companies. Within each of those areas, let's, here's something of no surprise. The bigger the piece, the closer it has to be to the water. So what's happening is that the industry is clustering around ports, clustering around Chris's Port, which I would say the whole area of Providence, Quonset, New Bedford, maybe Bridgeport, and New London. There's clustering taking place in New York and New Jersey, around the South Brooklyn, regions from Newport, New Jersey, etc. There's clustering taking place in the South Atlantic, which is Hampton Roads and Baltimore and the Port of Wilmington. And we believe that this is really what's going to happen in the industry, because as companies look to move in, and as these projects look to get built, they're going to go where like companies are. So you're going to see different segments of the industry have a higher concentration in certain areas based upon their physical assets, how much land they have, the depth of the land, obstructions. I mean, as an example, the Newport Bridge, which is 184 feet clear, correct?
196.
196.
We need those extra few feet. Don't steal
You
it.
can't be right all the time. You just have to be right most of the time. So 196 foot clear, that is a real obstruction. Some of these turbines, like I showed you in the first slide, if you look at a GE Howlite turbine, when you walk inside of one, it actually has 3 floors of stairs. They are just as big as a house, basically. And so shipping those in multiple sizes and the blades under So certain ports like Hampton Roads in Virginia with no obstruction is good for that kind of work. So the ports and the concentration of industry is really around the physical assets and the supply chain. And one thing that's interesting is everyone, it's all about the rate pay. Someone has to pay to get these built. And the cost of wind energy is more expensive than what's currently available. However, we can't keep burning coal. But what's happening is the size of these projects and the line of sight that companies have for multiple projects are driving the cost down. So within Southport in 2015 at 13.7 cents a kilowatt, dropped down to Mayflower Wind in 2019 to 7.8 cents per kilowatt. So there's great price pressure in driving costs down. When states go out for a bid to buy wind power now, one of the top criteria is your price that you give me can be no higher than the one you gave me before. So these prices are continuing to drop, and that's why we need to do things locally. So the opportunity has a direct impact on the price we're all going to pay. And then finally, about the timing, we're in 3 projects right now. That big green circle is where the industry is right now. So there's a great opportunity for people to become involved in offshore wind right now. These companies that are building these projects are anxious to find local partners and local suppliers. And so I would suggest that any of you are interested in offshore wind, you will find people that will listen. And with that, I will turn it over to Cotta.
I think some of my formatting might be a little bit off, but that's fine. So yeah, I was thinking about it. I had this slide on deck, and so the Vineyard Wind project is, I don't know how to describe that color, but it's below the green one, to the right of the green one. So that's the Vineyard Wind. That'll be built first as a utility scale project. That's 14 miles from the coast of Nantucket, and from Quonset, it's about 30 miles or 50 miles. The Revolution Wind's about 25 miles. So really it doesn't matter where you are from the coastline. It matters where you are from the nearest port, because that's where you have to take a vessel from. But yeah, so just this is a quick update on where we're at with Rhode Island. So the way we kind of organized and tried to frame this is Jeff was going to give you, here's what offshore wind looks like in the U.S. I'm going to tell you about Rhode Island, and then Chris is going to tell you about, what we're doing tactically on the ground and some of the successes we've had. So 2016, we built the Block Island Wind Farm. First one to the market. That was great. That was in state waters. 2018, we procured the 400 megawatt Revolution Wind project from Ørsted and Eversource. 2019, that was when Governor Raimondo put out an executive order that said Rhode Island needs to find a way to get to 100% renewable energy. And so that was basically an order that said, go figure out if this is even possible. That report came out in 2020, early 2021, a report basically mapping out a pathway of how to get to that renewable energy. So we know it's possible. Not only have we the initiative, but we know it's possible. And then in 2021, in the most recent session, the Act on Climate passed, and Governor McKee signed that, and that really gives us the incentive. So a lot of states are going out there, like you hear, North Carolina, 8.5 gigawatts. New York, I think, is 9.5 gigawatts. Rhode Island doesn't yet have that, stated number, but we have that goal with Act on Climate to do that. And then in 2021, there's a facility at Providport. I'll let Chris talk more about that. But really, today we're just going to, or in my section, we're going to talk about that section that can serve about 10 gigawatts just to the southeast of us, because that's really where our opportunity is as Rhode Island, and a little bit over into the New York Bight and south of Long Island, because Long Island doesn't have good port infrastructure. So, Rhode Island's offshore wind strategy, there should be a D there. But it works both ways.
But you want to win.
Yeah, we do want to win, so it works both ways. So this is kind of the strategy that we're approaching this with from Commerce's perspective. And the first piece of it is to grow locally, to find the companies in the wind industry, in adjacent industries that can compete in offshore wind. It costs about, if you're going to build a gigawatt of wind, it costs about $5 billion to do that, say. So, some of those contracts rolling out of there are about $1 billion each. You have to be a company that can take on $1 billion contract. And there's not too many companies in Rhode Island that have the ability to take that risk on and that on their balance sheet. There's a lot of great construction companies, there's a lot of real specialized companies, but they don't have that massive balance sheet where that's just a small piece of it. And it would kind of overwhelm some companies. So that's where, growing local, we find those companies that can compete. And then typically it's going to be a larger company, like Jeff was talking about, coming in from Europe that has the ability and the experience to take that on and then is procuring a lot of services locally. The second piece of grow locally is find our supply chain gaps and fill them. And that's really what Jeff's talking about with how do we get a local supply chain? We identify those gaps and then fill them in through attraction. The second piece is compete regionally. So Rhode Island, with the Newport and Jamestown Bridge, we have height restrictions. Some of the vessels that do this construction are 400 feet tall. So that's about 200 feet taller than Newport Bridge. And there's about 140 feet of water under the Newport Bridge at the deepest point. So even if you drop some of the legs down and you tried to go through, it still doesn't work. So even if, however unsafe that is, still not an option, just in case anyone was thinking about that. So we have to collaborate across our region. And that's where, if you look at the amount of procurements coming out of New York and New Jersey, we as a region between New London, Bridgeport, the Rhode Island port infrastructure, New Bedford, have the ability to be the relief valve for the industry and capture some of that, some of the spillover that just can't be served by New York's port, which is, I think, the largest container port, the largest chemical port, and the largest auto port for the East Coast. So they already have a well-established, filled out port infrastructure. And the last piece is innovate globally. And, Inspire Environmental is a great company here at Innovate Newport that's doing a lot of innovative things, developing some intellectual property and techniques that hopefully is going to be exported to the global market. We want to find those opportunities, those companies, support them, put them in front of the right people, get them into projects that are happening here, but then allow them to be exported back to Europe, export that technology back to Europe into emerging markets like Taiwan, Vietnam, and around the globe. And so these are just some companies that, meet each piece of that. And I'll say, the two, V2 Subsea and Inspire Environmental, both here in Newport and Middletown. So pretty cool to see that. Jeff talked about this briefly. I'm just going to go through, kind of hit on some of the pieces. I'm going to dive into the 4 phases of a life cycle of a wind farm. So developing and permitting, installation, commission, operation, maintenance, and decommissioning. I'm not going to cover decommissioning. It's 30 years away. If anyone has any questions, we can talk about it later, but in 20 years, I'll give that presentation of what the next 10 years will look like. So developing and permitting. I'm a naval architect by training, so I like ships. So each of these phases is going to have a lot of pictures of ships. So basically developing permitting, you secure a lease area, power purchase agreement, construction permit, and then the financial backing. That's really the most important part. None of this happens if you don't get the money to actually build a wind farm. It's interesting, the Cape Wind project got through all those phases except for financial backing. So they bruised and battled their way through all of it and left themselves so damaged that they weren't able to get any money to build it. So that's not the way to build a wind farm. I don't think we'll see anyone take that strategy in the future. So just looking at some of these aspects, one that I want to point out is the environmental surveys. Benthic habitats, that's the seafloor, everything that lives on the seafloor and what the impacts will be. Fish and shellfish. Ornithological, which is the birds, I believe, yes. Birds, sea mammals, onshore environmental, and then even human impact studies. So all of these are different environmental studies that go into actually permitting a wind farm. There is about 1,500 pages that goes in on what the effect is going to be on each piece, and then the ongoing survey. And if you go into the record of decision for Vineyard Wind, they established in those 1,500 pages of federal permitting what their inspection regime was going to be, and then the Bureau of Ocean Energy Management went in and added another 10 pages of inspections and monitoring that they had to do. So these things are absolutely just constantly monitored. This is a type of vessel that you'll see doing this surveying. So this can do geophysical, geotechnical surveys, go out there, understand what's on the seafloor, what type of soil it is, what type of foundation you need, and if there's any unexploded ordnance from World War II sitting on the bottom of the ocean, this thing's going to find it and hopefully remove it. So that's a typical vessel you'll see operating during this phase. And that's where we are for pretty much every project right now, and hopefully Vineyard Wind will move out of this phase and onto installation and commissioning. Once again, picture of a large ship. This vessel in the top right, when you look at it, those legs that it's standing on are touching the seafloor. This is what's called a jack-up vessel. So it puts those legs down on the seafloor, creates a stable platform in order to lift a blade. The biggest components they'll lift are probably the nacelle, wherever all the blades connect in, and those for a 15 megawatt turbine are about 500 tons and need to be lifted, 600 feet in the air, something like that. So heavy lifts of large items very high in the air. When you talk about constructing a wind farm, there's really two components to the supply chain of it. There's the turbine, and then there's everything else. And everything else is called the balance of plant. And so if you look at this picture on the bottom right, this is actually from Dominion Energy, talking about the Coastal Virginia Wind Farm, but is how most of them are going to look. You see the turbines, but then there's the foundations, the cables, the substation offshore, more cables, and then how it actually integrates into the transmission infrastructure. Most of our grid today is designed so that the coast is the end point of the grid. Right now, what we're trying to do is reverse that. And now the end point of the grid is going to be the beginning point for inputting power. So all of the capacity that you have at the coastline, it kind of, think of a funnel going down. We're now reversing that funnel. So there's a lot of changes that need to be made, but that's where Mayflower Wind is actually tapping into the old Brayton Point power plant, which has 1,600 megawatts to use that transmission capacity. Operations maintenance. These are some of the vessels Jeff was talking about with crew transfer vessels. On the top, you have an SOV. That'll go off for 2 weeks at a time. On the bottom, you have a CTV. That'll bring people out. These are just some more components of the supply chain that's going to exist for that, from turbine maintenance, balance plant maintenance, all the logistics, the training, and then inspections. Once again, inspections, monitoring, and health and safety is huge in this industry. Anyone who's looking to get into offshore wind should understand that health and safety needs to be at the forefront of your culture and your company if you're going to compete. Project development timeline, I think Jeff did a good job with this, so I'm not going to go into it too much. Basically, you need a lease area, you get a price, you do your construction operations plan, and then a lot of permitting, and then you can start constructing it. So I'm from Rhode Island Commerce, so this is kind of where I guess I'll put in my sales pitch of how we think of this. There's local companies that we're trying to connect in with the bigger players, but the other piece of it is attracting in those bigger players or specialized skills to fill those gaps. What we've seen as a model that works is providing them a soft landing. So they usually have one person go to a co-working space, come to the area, find out who the players are, find out where they can start to build that supply chain, and we do matchmaking through Supply RI, which is a great organization under Commerce that connects small businesses throughout the state with the larger procurers, and then we help them establish their local supply chain. And at that point, once they get a contract, once things are being done, we have areas where we can help scale to meet demand. And so that's actually a facility at Quonset that's going up. And there's a lot of building going on at Quonset in order to support this industry and be in the port. So there's also a lot of building going on at Provport, and that's where I will turn it over to Chris.
Thank you, Will, and thank you all for having me. So yeah, I'm going to talk specifically about Rhode Island port infrastructure. So like Will mentioned, Jeff started real big picture, and then we're funneling down to a pretty specific piece of the industry. So I'm the bottom of the funnel, if you will, which is where I found myself in college a lot. So Waterson Terminal Services, as you can tell by my last name, is a family company. It was started by my father, Bruce, back in 2000 at Provport. Since then, we have expanded operations to the Port of Davisville. Right now we're handling all the Volkswagen and Audi units that are being imported through that facility, and working as licensed stevedores at the New Bedford Marine Commerce Terminal, which is where the Vineyard Wind project will primarily be staged from. We offer a suite of services from port security, equipment rental, but the primary piece of the service is unloading and loading vessels at the ports that we operate in. Oh, should have been struck through. I think that was just a formatting thing. So one of the things I just wanted to mention, what we're very proud of, is our Green Marine certification, which is a program that we've been involved in since 2018. This is an industry sort of organization with a goal of incremental improvement year over year on these several categories of environmental performance, and including community impacts, because there's a lot of community interest around ports and the neighborhoods that are close to them. So we're very cognizant of that, and we think that our involvement with offshore wind and some of the new businesses that we're getting into is helping to take the Port of Providence, which was primarily a fuel terminal, coal historically, bringing it into the 21st century and investing in renewable energy opportunities to limit the impacts of the port on the Newport community. So as was mentioned, we are and remain the only U.S. Port and terminal operator that has handled an offshore wind project in the United States. While there is a facility that was built down in Virginia, believe it or not, that project was actually constructed and marshaled out of Halifax, up in Canada. And that was due to the Jones Act, which is a law in the United States that only allows cargo to be transported from a U.S. port to a U.S. port on a U.S. flag vessel. And these vessels that these gentlemen have been talking about do not exist as U.S. flag vessels. They're only European flag or Asian flag. So for Block Island, we handled all of the importing of turbines and blades. You can see us, those are our 2 port cranes at Proud Port lifting a set of 3 blades for the GE 6 megawatt turbines that are spinning off of Block Island right now. So all of the import of the cargo, pre-assembly, and preparing the cargo to be loaded on an install vessel and constructed out at the site. So a lot of good lessons learned during that process. We did a lot of training with the local longshoremen unions and the building trades, worked in some sort of precedent-setting flexible hours, because all of this is really critical path. The vessels are very expensive. When they come in, they need to be loaded and sent out to the site as quickly as possible, but also as safely as possible, as Will mentioned. That was first and foremost. So getting the local labor to understand what the requirements are of the industry really gives us sort of a leg up on the rest of the ports up and down the East Coast that are working on this now, because they simply haven't done it. And also through that experience, we realized that some of the core competencies that we already had at Proud Port, which is primarily bulk material handling over the years, there's a component of that in offshore wind as well. So every single one of these foundations has up to probably 5,000 to 10,000 tons of stone at the base to protect the seafloor from washing out and undermining the foundation. All that stone needs to be marshaled at a port. So when you think of wind turbine, offshore wind turbines, you think of the towers, the nacelles, the blades, but there's so much more in the supply chain, and we've figured that out over time and working in this industry, and we're pretty well positioned to handle that here in Rhode Island. So I just like to always show this. I'm going to not spend a lot of time on it, but there's sometimes confusion between Port and the Port of Providence. Proudport is everything you see in blue there. It's the former city municipal port that was privatized in 1994. Every other terminal up and down the Providence side and the East Providence side are all private terminals. It's land that's owned by, say, Shell, that has their own fuel terminal. So we don't have any involvement in that. So Proudport really is the most like a port authority, for lack of a better term, in Providence. I also want to point out the South Key terminal on the East Providence side. I'm going to talk a little more about that later, but that's a really exciting opportunity to develop more port space up in the Port of Providence. So now to the good part that Will was getting at. So just a couple months ago, Ørsted and Eversource announced constructing of a new facility at Proudport, which will fabricate components for their first tranche of projects for South Fork Wind, which is delivering power to New York, and for Revolution Wind, which is delivering power to Rhode Island and Connecticut. So that building, while it doesn't look like much, you can kind of see the little people in the front there for scale. It's going to be roughly an 80-foot tall building. All the components in there will be assembled in the upright position. It's called internal platforms. It's the interface between the cable below and the turbine on top. There's a lot of electronic switching equipment, so there will be electrical workers, iron workers, painters, millwrights, all working at the Port of Providence fabricating these components. There'll be external platforms, which is what the technicians in the future operation and maintenance phase will land on to gain access from the vessel to the turbine. That'll mostly be cast out of concrete, but then we'll add railings, and each one will have a little crane on it so that supplies can be lifted up onto the platform. So that'll be fabricated at Proudport. And then finally, anode cages, which slide over the outside of the foundation and protect the steel from corroding from the saltwater environment. So all of that is actually under construction right now. Within the next probably 3 to 4 weeks, you'll start to see steel come up, and it'll change the skyline of the port a little bit. So it's very exciting that that's going on. And Ørsted is making that investment. Ørsted and Eversource are making that investment in the port, which means that they're committed to the port, and they expect that to be a long future of projects that will be worked through Proudport. So because we're behind the bridge, this manufacturing, fabrication type of operation is really what Proudport, East Providence, and maybe even Quonset will be doing in the future. Ports like New London, Connecticut, outside of bridges, will most likely be marshalling ports, because the tower will actually be built almost entirely on shore and placed in one piece onto the vessel. That'll be about 300 to 400 feet tall, so you can't get under the bridge, as Will mentioned, and you definitely can't put the turbine in the water to drag it under the bridge. So just quickly want to touch on Quonset and the Port of Davisville. So their master plan involves a lot of work for operations and maintenance. So creating a facility for those crew transfer vessels, those SOVs, as well as even helicopter operations out of the Quonset airport to quickly shuttle technicians out to the site faster than obviously a vessel can get there. They're also focusing a lot on workforce development and training infrastructure, like Will mentioned, building out those facilities. One thing they have at Quonset is a lot more land than what we have up in Providence to work with. And I'll talk about it later, but both in Providence and in Quonset, there's competing uses. We have an existing group of tenants in Proudport that use the port. Obviously, all the car imports in Quonset are great for the port, but make it a little challenging for the offshore wind industry, because there can't be traffic at the port to block vessels from coming in and out, and you need a lot of space along the quayside. There it is, okay. And I mentioned the South Quay earlier. This is a really exciting project. There's about 65 acres on the East Providence waterfront, mostly created from the original dredging project back in the 70s. So this is reclaimed land of dredge materials. It's all clean, and the best part about it is that it has a federal Army Corps permit and a CRMC permit for marine industrial use. And probably one of the reasons why it hasn't been developed since the 70s is because no one wanted a marine industrial use. But now with offshore wind and the clean energy component to it, a marine industrial use is suddenly attractive again. So we're working very closely with City of East Providence, the state of Rhode Island, and our federal delegation to hopefully develop that site. It's about a $100 million project to create the heavy bearing capacity quayside and the uplands improvements in order to support these massive components. So I can see it out of my office. I look at it every day, and it's really a natural fit, almost looked at as an expansion of Proudport, even though it won't be called Proudport. So Waterson Terminal Services, as the terminal manager, would be working in both locations and can really use the two facilities in conjunction with each other, which will be really attractive to the industry. So I've kind of mentioned some of the challenges. I like using this picture. This is the port of Esbjerg in Denmark. So this just gives you a sense of the size of the turbines fully erected on the quayside. You can see a jack-up vessel in the back there with its legs sticking out those trestle legs. So this port is 2,000 acres. Proudport's 115 acres. One of the biggest challenges just up and down the East Coast is there's not a facility that exists like this. So whereas in Europe it's mega ports, all the projects get staged out of the same port. In the US it's going to be a network of ports. So in the Northeast, like we've mentioned, Proudport, New Bedford, Davisville, New London, possibly Bridgeport, all sort of working together and playing to their strengths in order to deliver these projects. So it's going to be a different looking supply chain than it is in Europe. And we have to convince the Europeans that that's the case as well. There are going to be different vessels involved. We can't use these massive vessels to get into this port, so we might use a barge feeder system or smaller vessels to shuttle components out to that large vessel that'll sit offshore. There's also the Jones Act that we have to deal with. So I've mentioned competing uses already. There's also the cost of improvements. Unfortunately, it's a very high cost of improvements, and these contracts for construction projects are only 2 to 3 years. So you can't privately finance a massive $100 million project on a 2 to 3 year lease. So that's why we have to go to the state and the federal government, and we're really excited about the prospect of infrastructure bill and hopefully having more funding to invest in our ports to help support this industry. And then we talked about all the states and their power goals. Right now, New York is leading because they say we're buying 9.5 gigawatts. That's taking all of the developer money, all of the supply chain money, and they are focused on New York because there is such a big pipeline in that state. So where are we going to invest in port infrastructure? Are we going to invest in Providence, or are we going to invest in New York? So one of our biggest things is making sure that Rhode Island puts out that goal so that there's a carrot for that development community to come in and say we need to invest in Rhode Island ports as well. So that's probably our single biggest challenge, is just the size and the power demand of such a small state. But I think eventually the port infrastructure is going to win out because it's already happening. It's going to be here. We have a first mover advantage, and once we're established, we're going to keep supplying these projects for years to come. So with that, I think that's it. And
if I can just add one thing on that, I think Rhode Island's opportunity with ports to kind of pairs with that in New York, where there is so little port infrastructure, there's so little ports available in the Northeast, that when the developer comes in and leases out the port and says, I'm going to use this, they then go to their suppliers and say, okay, now you need to find your own port. That's where I think our opportunity is, regardless, because they go in and they have a lot of pressure to be local, to raise flags, say, we're here, and that's where we can go in when their suppliers are challenged with, now you need a port, and they aren't allowed to operate out of that port because they're, different scope of work or something like that. So that's where we are hoping to kind of jump in and say, we need to continue to develop these ports and hopefully get some leases from them and push some of the risks onto them as well to make sure that they're getting contracts and stuff. So.
Jeff, Will, Chris, thank you all so much for your presentations. I think now we have about 15 minutes of time if anybody has questions.
I don't know where to start. Well, let's start where we ended, though. I think that was a good place. So, as I understood what you said, Will, is that we have an opportunity in Rhode Island to capture some of the supply chain companies here that can't afford or don't have the ability to set up shop in New York or New Jersey, where there are lots of gigawatts. What are the challenges then for them? Is it shipping lanes? Is it cost of rail travel? What are the big challenges? Challenges for getting them in here. What do they see as
a lot is local content. So if you're in the New York project, New York has a very strict local content requirements, and they'll say, you need 75% of the jobs to be here. So that developer and maybe the OEM, the people at the top of the supply chain, are really going to be pushing to put their people in there. People further down the supply chain who have a smaller scope of work, there's not necessarily the expectation that you'll go in and set that up, or really the oversight on it. And so where we have expectations, like Equinor is a company that has a lot of New York projects, they've been very much investing in there, and they continue to invest in there because now all the people are there, so it makes sense for them. I think that's where we can, a little bit further down the supply chain, grab these companies that may come in for a specific scope of work and not necessarily see that same local content pressure. And I really see Rhode Island as the relief valve for the industry. When somebody's looking for an opportunity, where do we bring our ship, where do we go? Hopefully we can be that solution. Did you have a question?
Yeah, I did. Well, after that answer, I kind of have two now. But I'll go with the original one. You guys touched a little bit upon, or you went into the overview of how many years it takes to get from idea and place where it's going to be built to having one of the wind turbines actually running. And in terms of the pain points of that funnel, what would you think the biggest pain points are right now?
I think there's two. I think the environmental work is very difficult because people like to spire upstairs. There's 50 companies doing all kinds of work. There's even people that go, don't forget, the country was larger 300 years ago. So when they do surveys, they look for archaeological artifacts as well. So surveying takes place. It's not just where are the fish and the big rocks. It's was there a settlement there? What is the fish migration, avian migration, mammal migration pattern? So I think that's a huge pain point. It's just the permitting process. Another pain point is the Bureau of Ocean Energy Management, which is part of the Department of the Interior, where all this has to go through, has been grossly understaffed. There's currently 11 COPs, construction and operation plans, sort of the final document before you can build, that are just sitting in Bowl right now waiting to get approved. So that's a big pain. But I would say it's the environmental. It's the environmental survey. It's also stakeholder management. There's a lot of people that have interest in wind farms. There's the fishermen. There's coastal resources management. There's Audubon Society. There's the Nature Conservancy. There's the recreational boating industry. There's the Coast Guard. There's shippers, etc. So there's an awful lot of stakeholder management that has to take place. So I think permitting and stakeholder management are two of the biggest, and then bulbs backlog are the three biggest pains. I don't know if you guys agree with that.
It's always their problem, I guess.
Those are ratepayers, we're not anybody.
Well, I mean, yeah. And the prices come down so quick, but we're in the permitting phase now, so I think that makes sense to a lot of the pain points. It'll be interesting to see once we get into the construction phase, what new pain points emerge around how they actually build wind farms in the U.S. Everyone has their plans, but there's going to be challenges that haven't necessarily been solved. So it'll be interesting. I think throughout the process we're going to see pain points, and then in 20 years I'll give you my decommissioning. That's a huge problem. I mean, as Chris mentioned, that jackup, there's one of them being built in the U.S. right now by Dominion. It's $1 billion ship. And, so we don't have...
It's not built yet?
What?
So you're building it now?
It's being built. It's being built.
Being built and it's being planned on being used to construct.
It takes like 3 years to build, too, right?
Yeah, it takes about
So you have to
3
wait
years
until
build.
this is built before you can even start the construction, it seems like.
And it's already, I think it's already leased for 4 years.
Yeah, it's coming out of the shipyard and going right to New London, and we'll be building the Yorkstead project.
So it's already leased. So you have a ship problem. That's because of the Jones Act. As Chris said, the Jones Act basically means it's not a U.S. built, U.S. crewed, U.S. owned vessel. You can't go between, you can't ship goods between port to port. So we have a vessel problem.
But if, sorry to interrupt, but if you get it out there,
That's
The construction site in federal waters is a U.S. port.
You're saying a feedering barge. Yeah, so a feedering barge, if you're European and you jack down, then you are stationary, you are not moving, then you're just a crane, barge goes up.
Barge can show up.
Oh,
There are ways,
okay.
but they're not even enough
So there's a
barges.
way around.
But they're not even enough barges, so we have a ship problem as well. And there's an interesting thing that I'm sure Chris keeps Chris up at night. You know, he already has a port business. He's got ships coming in and out all the time. Now his vessel traffic is going to increase rapidly. So how do you manage all this new vessel traffic? This is a real problem. You're going to all of a sudden have double, triple the amount of ships within a very contracted period, so that's an issue as well.
That may be priority access because of the cost of the vessels.
There's an app for that. And usually some startups working on that.
Yes.
So I just want to know like the scale of this project, but how many gigawatts does Rhode Island use right now?
So we consume, so that's a tough question. It depends on the second. If everyone turns on their air conditioner at the same time, like to turn on an air conditioner requires like 3 times as much power as operating. And so you can actually black out a grid. If everyone just managed to turn on their air conditioner at the right time, we would just black out the grid. And so, so we consume, I think we need, in order to get to the Rhode Island plan, basically for decarbonization, we have 400 megawatts of offshore wind coming from Revolution Wind. We have a lot of efforts with solar deployment onshore and some wind onshore. But we need about 1.1 gigawatts of additional offshore wind in order to have both not only our electrical system, but heating, so moving away from natural gas and towards heat pumps to provide heating and air conditioning at the same time. And transportation as well. So transportation, heating, your electrical system, you're going to need about 1.1 more gigawatts of offshore wind. And then again, you can look at the whole like curve and everything. Whenever we come from work, turns on our lights, runs their laundry, it jumps as well. So.
I just have a technical question related to the slide that's up there, and you talk about the bridge and clearance and 300 feet. I think 300 feet would probably be the tower vertical. And so I'm kind of going through this as a mariner myself. The jacked up vessel that is on the seabed, it's stationary. Is the problem with actually shipping and clearing that is that you don't have the ability to go from horizontal to vertical, and you need to ship vertical?
Exactly.
Yeah.
Okay.
Yeah, so the process of operating the tower section requires 2 cranes, and the vessel has one that's capable of lifting, so there's not enough space on the deck to do that operating operation as well. So that's why they get shipped vertically, and it's to also maximize the amount of space on the deck. So these ships in Europe are going out with 6 to 8 full turbine sets, towers, and cell plates all on one shipment. So that they are not going back and forth in the port, because when they're transporting from the port and back, they're not building, which is really what they should be doing.
And just to give you some context, the vessel that Jeff's talking about being built down in Brownsville, Texas, that's going to cost about $500,000 a day to operate. So like if you're leasing that vessel, you're paying $500,000 a day. So if you need 2, now you're at $1 million a day. And then the reason they try and cram as much stuff on there as they can is for the way they build these. They cram as much components on, go out and build maybe 4, 6 of them, however many they can, and then have to go back. That transit time every hour is about $20,000. And so that's why when you look at, helicopters are expensive to operate. All of those vessels that I showed pictures of have a helicopter landing pad on them. So you need a part, and you say, okay, now we got to steam back in, and that's going to be 10 hours. So it's $200,000 for that part. At that point, you can bring a pretty big helicopter out and get that part on there. So that's where a lot of those logistics, it just gets, a 500-foot vessel is an expensive thing to build. And so I'm sure if you're a mariner, I'm sure you know that as well. But it gets challenging with, like these are solvable problems, but doing it in a cost-efficient way is really the challenge.
Yeah, it's interesting in terms of right down to the logistic of just erecting from, horizontal to vertical.
Yeah.
Very interesting.
Yeah.
It's also an aspect we haven't talked about, which is cables. Cables have to go through between all these turbines. They're 1 nautical mile apart, so 1.1 mile apart. So you've got cables between the turbines going to the substations going into shore. So you have to lay miles and miles and miles of cable. These reels of cable are, it's as big as this room.
5,000 tons of cable.
Yeah, 5,000 tons of cables, which are like this. So that's a vessel, a whole fleet of vessels. So that's a real, just a sort of a fun fact, that port, which I've spent some time at, when they load those on a ship, so they load the blades, the nacelle, and the tower, they have it erected in 12 hours, it's generating power in 24 by the time they get it for foundation. It's unbelievable how quickly they get them going.
Can you say something about maintenance of these things? You know, you're projecting, what, a 20 to 30 year life? And do they need major rebuilds sort of partway through? Or is it just a case of renewing sort of bearings in the generator?
Yeah, so the power purchase agreements are typically, when they sign the contract to buy power, they're 15 to 20 years. So they do a life cycle of 20 years of what they do for the engineering analysis. But with engineering, once you start, there's so many safety factors involved that once you start doing beyond 30 years and you do like cycle assessments, it just gets ridiculous, and you're not going to be able to build anything. So what they do is they build them for 20 years, a design life cycle of 20 years, and then they go in at 20 years and say, is it still within the tolerances we would expect? Okay, it is. Then we do a life cycle extension, and they do that in the oil and gas industry, in offshore energy. So I'll let Jeff talk a little bit about the maintenance side of it. But the design, when they say it's a 20-year life cycle, that's just because I'm an engineer by training. So like when you do the cycle assessments of that, if you were to put in your safety factor for what a 40-year life cycle would be, the ship would be, or the turbine would be unbuildable because there's just so many safety factors built in that it's unnecessary.
Blades are one of the things that need sort of regular maintenance, every 3 to 5 years. The gentleman sitting in front of you wax poetically about blade maintenance.
Don't go there.
But, they have leading edge problems because of the salt hitting the blade. Don't forget, these blades on these GE allied 100-meter blades, the tips are traveling almost at the speed of sound. So hitting a piece of salt is like hitting a piece of dirt or a rock at that speed. So there's some leading edge on the blade that has to be done. There's obviously ongoing maintenance for the torquing of the blades, for the maintenance of the cell itself. There's inspections that take place with a scour, which are the stones around the foundation itself, to make sure the foundation still sits. So they're continually being maintained. So there is maintenance and operation work that has to take place, and it's typically concentrated by seasons. Someone doesn't climb up a blade in February, and they do in June. So there's operational constraints by weather, which is actually an interesting problem because if you hire a crew and say they were here July, right, when we had such lousy weather, you're still paying for those people who are now working. So maintenance is a very expensive process.
So the blades have renewable leading edges, like big steam
They
turbines.
repair them. They actually repair them.
Yeah.
And they have sensors in them to detect, the vibrations. So there a lot of the components do have, Internet of Things technology on them and are being monitored. So you hopefully can do a lot of preventive maintenance as well.
What about painting the tower, or what's the outside surface of the tower?
Yeah, I'm sure that has to be. I don't really know that, but I'm sure it has to be done.
We're close to time.
Where do unions fall in this, and labor in general? It's great you're talking about companies and small businesses, but the labor is...
It's an integral part. So each project, so starting with Block Island, is a project labor agreement with Rhode Island Building Trades, and that covered ironworkers, operating engineers, electricians, millwrights, carpenters, painters. So that happens on the construction side, which is onshore and offshore. It's actually, Block Island ironworkers are on a vessel to basically on-the-job training of how wind turbines get installed offshore. So they live on the vessel during construction. And then on the port side, it's the Longshoremen's Union. So we're an employer of the ILA, and they will be hired in for every single vessel that comes in, every single vessel that gets loaded out. So it's all union labor on the port side as well. So especially in this area of the world, that will be an integral part. I think up and down the East Coast will all be built with union labor.
And for the Newport wind project, they just signed a project labor agreement for probably less than a month ago. And it has 500 union jobs with 20 local unions for the southeastern Mass Building and Trades Council. So, yeah, I mean, they're very aware of it, and they know how to negotiate these project labor agreements and stuff. And we see with Vineyard Wind there's going to be a big role in it.
And one of the value adds for local companies, like us, we already have that agreement worked out for the union. So if European companies coming over, they're scared of American unions. All they have to do is contract with our company, and then they get the union along with us. So we de-risk that process for them, and just provide the labor that they're required for the contracts and our purchase agreements.
Can I just ask, Jack, you talked about stakeholder management. Who is, leading those conversations? Who is responsible for that?
The developers typically do. The developers have a fairly extensive stakeholder organization. And, what we found, like Will mentioned earlier with Cape Wind, a lot of that was missing. A lot of that was not very well done as far as stakeholder management and the lessons learned there. And so the developers really try, and what is a learned lesson is get stakeholders involved very, very early in the process and have them part of the conversation. Because, I think one of the ways that people used to look at this as adversarial, they can actually be very helpful in bringing up things that typically developers don't understand. So stakeholder management is really important, and by the developer, and also the integration of stakeholders. So, who is the stakeholder, or who should those stakeholders partner with in order to come with a comprehensive plan? But it's with the developers.
Yeah, at the end of the day, the developers are the ones who have to do permitting, get to that financial close, get $5 billion to go build these things. If you injure your company's reputation so much during the process by not listening to stakeholders, nobody's ever going to do business with you. And so that, it's very important for them to be able to engage with those stakeholders. I used to do a lot of marine salvage. I'd fly in and there'd be a big oil spill and some pristine beach, and it was often to Jeff's point about integrating the stakeholders. People who may have competing, interests in the project, different environmental groups or, construction groups, something like that, you put them in the same room and say, how do you want me to build this? How do you address your concerns, and having them discuss amongst themselves? They can sometimes come to a solution that works for both of them. So it's not always on the developers they need to manage all those stakeholders, but they also need to listen to all the different people and put the right people in the room to understand how they can work together as well.
Any other questions?
Estimated how many years does it take once one is built for it to be profitable?
I can tell you the typical return is anywhere between 6 and 8%, but it's over a 20 to 25-year period of time. If anyone in this room would like a guaranteed 8% over 25 years, raise your hand. I don't know what the exact date is.
I'll say the financial numbers, they keep those pretty close to Jeff and the developers, because that's, when you look at a company like Waterson or Vineyard Wind, they're not an offshore developer, they're a finance company. The companies that come in and they hire, those are the ones who actually do offshore construction, actually build things. But at the end of the day, they're really a bank that, finances this project and manages the contracts. So think of them more as a finance company that happens to have some people who know a little bit about this as well. But the people actually constructing it, those big contractors, those are the ones with the expertise. And that's why you have these developers coming in, building these lease areas. But that's why we're bringing in a lot of companies from Europe as well, because it's just really challenging to build a gigawatt of offshore wind, or let alone 30 gigawatts.
Thank you all so much for being here. Really appreciate your time, and thank you all for coming. Come back next week.